Good afternoon, everybody. I'm pretty happy to be here in the city of Austin. I love music and in general live music, so this is really a great city for me. So my talk of today is titled Lint Fast, Type Hard, and I'm going to show you how you can elevate the code quality in Python with modern ultra-fast tooling. My name is Miguel Vargas. I'm a software engineer from Ecuador. I have over a decade of experience, and I have been involved with multiple startups in different industries like healthcare, fintech, real estate, and nowadays, law tech. Technologies that I have been working are Python with Django, Lightstar, FastAPI, and Flask on the backend side, and also with front-end technologies using TypeScript like React and Next.js. I'm very passionate about math, science, AI, and robotics. Okay, for the ones who do not know where Ecuador is, so it is not in Africa, it is not in Asia, okay? It is in South America, south to Colombia, so there we are in Austin. Ecuador is there, right to the south of Colombia. But this talk is not about my country. In fact, that line that you can see there is the equator, and the country is named after that line. So let's go back to the talk. That is about code quality. Why does it matter from the business perspective? So poor quality code increases operational risk, which means more bugs, more outages, more team burnout, and fixing a bug in production is way more expensive than catching it in development. From the developer perspective, code reviews can focus on design and architecture and not in formatting or style debates. Also, tools that allows linting, type checking, and tests can handle repeated feedback automatically. And very importantly, refactoring becomes safer, so developer can make changes with more confidence. And in the AI era, why is it important now? Because, agents can perform notoriously better in a clean, well-typed, well-tested code bases. So quality now is an input to the AI productivity. And that as developers, we are reviewing less and less code. So these automatic checks matter even more. And AI speeds up coding, but without these guardrails, it also is going to speed up the technical debt. So AI can help teams move faster, but code quality is what makes that speed safe. Now we're going to talk about some terminology. I'm going to go real quick through this terminology, but it is important to help you to tell you about what the tools that I'm going to talk about are covering. So the first acronym is SAST. That stands for Static Application Security Testing. So this is basically scanning your code without running in and finding vulnerabilities like SQL injection, XSS, and also tracking and save data flows. So SAST focuses on security. Now SCAT, which stands for Static Code Analysis Tool. It analyzes code without running it to catch bugs, style issues, and code smells. Code smells basically are like anti-patterns like nested ifs, nested for loops, and let's say functions or methods that have so many lines of code. SCAT also enforces coding standards and improves reliability, but the main thing is that it focuses on code quality and maintainability. And finally, SCA, which stands for Software Composition Analysis, scans dependencies and open source library for known vulnerabilities. It provides real-time alerts and automatic dependency updates, and it detects outdated or risky packages. In essence, it focuses on third-party dependencies. So we have platforms that offer a comprehensive features, but they come with significant cost. Probably the most popular ones and some that have really good tools that are offering really good tools are SonarQube, Codana, SemGrid, Sneak, Veracode, and Black Duck. Particularly the last three, Sneak, Veracode, and Black Duck, they offer really good tools. SonarQube, Codana, and SemGrid, they offer some free tier available, but they are quite limited. And on the other hand, Sneak, Veracode, and Black Duck, they offer solutions that You can commit to a contract that is over $15,000 per year, which for a small company, I have been working for small companies over the last 8 years. For a small companies, like, it's something that we might not can afford at that moment for a license that is going to allow between 10 to 20 developers to work with these tools. So what I'm going to talk about is about open source alternatives that probably are not as comprehensive as these enterprise tools, but they cover a good part of what we're trying to cover. So we have tools like Ruff, that this is a total game changer. It's been written in Rust. It's an ultra-fast linter and formatter, and it's replacing several tools like Black and Flake 8. We have Pyrefly, which is a type checker developed by Meta, also written in Rust. We have Type, which is another extra fast Python type checker. And we also have pip audit, which allow us to do some SCA to scan third-party dependencies. So this is the official Python tool. So I'm going to talk now real quick about Astral, which is the company behind modern Python tooling. This is Charlie Mars. He is the founder of Astral, and he created Ruff as a side project in 2022. Then he founded Astral in 2023, and he thinks that Python tooling should be rewritten in Rust for speed, because Rust is ultra fast. So far, we have 3 tools that have become real popular. They are UV, which is not only a Python package manager, but also it allows you to manage Python versions. We have Ruff, that is a linter and a formatter, and we have Type, that is a type checker. All of them written in Rust. Exactly 1 month ago, on March 19 this year, OpenAI announced the acquisition of Astral. And as you can see in this tweet, they said that Astral is going to be part of the Codex team. After reading, Charlie March posted a post on his blog, on the Astral blog, and he says that he believes that the highest leverage next step for developer productivity is AI-assisted software development, and he sees Codex as the place to push that frontier. So he's going to keep developing this tool in order to improve software development. And now, before I start talking about these tools, let's understand first the difference between a formatter and a linter. So what's a formatter? This is a tool that automatically rewrites your code to enforce consistent style without altering the functionality. It standardizes elements like white space, line breaks, and quote styles. Benefits that it brings: no more style debates like, you should use double space, 4 spaces, like double quotation marks or single quotation marks. Cleaner code reviews, and faster onboarding team, because you don't have to tell the new developers what is the way and the style that, that we write code in the company when he joins. Some examples of formatters in the Python realm: we have Black, and we have Ruff in format mode. And now let's define a linter. So this is a tool that analyzes code for potential bugs, code smells, and security risks. It flags issues like unused imports, undefined variables, fragile exception handling, and unsafe patterns like hard-coded secrets in the code base. Benefits that it brings: it catches bugs early, it definitely improves code quality, and it enforces team coding standards. Some linters that we have in the Python realm are Flake 8, PyLint, and Ruff in the check mode. More about the modes in a moment. So Ruff is a formatter and a linter. So Ruff is from 10 times to 100 times faster than existing linters and formatting. And it allows you to go from n tools to one tool. So probably before Ruff, what you had in your repository was Black as a formatter, Flake 8 as a linter, isort as an import sorter, PyDoc style to check in doc strings, banding for security. But after Ruff, we started having everything in one tool, just all of this controlled by rules. And why is it a game changer? Because it's built in Rust, which means that it's memory safe, but overall it's really fast, even with really large code bases. And you can use the autofix that has Ruff, so you don't have to spend time cleaning up the issues that you have. You can spend more time on design and architecture. And Ruff is becoming an industry standard. It's being used by Fast API, Pandas, Airflow, Hugging Face, and By today, last month, was downloaded over 187 million times. I took this from the PyPI stats. So Ruff has a bunch of rule sets. It has over 900 rule sets. And they have some categories, like some of them are for errors and bugs, some of them are for style, that they have compliance with PEP 8, that is the Python standard for best practices when coding with Python. You have, for dead code, like unused imports, variables for unreachable call, for code that is just commented. And you have also some rules from Bandit that were implemented for security, some rules from ISOR for sorting imports automatically, and also some rules from PyDoc style for docstrings. As we can see here, this is the link for the official documentation of Ruff, and these are the rules. It has over 900 rules, and here you can see that they have different, all of these rules, the categories for these rules, and we can refer each rule by. Each rule has a code, so we can see the code for this, and if we click on each rule, you can see that why it does, why is it bad, an example of when you're doing it something that is not properly done, and how to use it instead. By default, Ruffs enable the flake 8 rules along with a subset of the error rules. Okay, now we're going to make a demo. Okay, Ruff says that first we have to apply the lint fixes before the formatting. So let's go to. I'm going to use cursor. Let me see if you can see it. Okay. So I'm going to use cursor. I'm going to open the editor window. And I prepared this file for the Ruff demo. And as you can see, I am getting these warnings here because I have the extension for type and for Ruff enabled. Let's go back here. So what I'm going to do first is let's run this command here that is going to tell me what are the errors that I have. It's going to run the linter. So I have all of these errors. What I'm going to do next is I'm going to use my agent. I'm going to use the Model Composer 2, which is the model that Cursor released, I guess, 3 weeks ago, which is quite good. It's even better than Opus 4.6, but way cheaper than that model. So I'm going to use some prompts that I got ready for this. And this prompt says that it's going to run the check, fix, wrap for that file, and then the fix and save. And then after each run, it's going to explain what got fixed. So I'm going to run it. And I'm going to see this file here. And I would like to see the changes that this is doing. So the lines in red are the ones that got changed. And right now, there we go, have the output here. So what it's saying is that after running this Ruff just with the fix command, the auto fixes, it was able to save 3 errors. And they were unused imports that, as you can see, they got removed. It also removed this f string that was not using a variable inside, so that got removed. And also, after running the fix with unsaved fixes, it removed variables that were not used, like this one and use var, that was just assigned a value, but this got removed. And also, it removed, like in Python, the way to check if something is none is using the keyword is, not the double equal sign. So it changed that. And now I'm going to ask it to commit these changes so we can see now Ruff in format mode. Let's move over here. And so for the format mode, I also prepared another prompt. OK, so the changes were committed. That's the reason we no longer see them. And the prompt this time is format this file via UVX. So UVX is a utility. UV is the tool that I told you that manages Python, the package manager and the Python version manager. But UVX allows us to install tools and also to install them in isolated temporal environments. So when I use UVX, this is going to install Ruff, but it's not going to install it in the system. It's just going to be temporarily installed, just for the purposes of this demo in this case. So I'm going to format this file. And we can see that, yeah, it did the changes. And now it's going to summarize the changes that we made. So it's saying that it removed some extra leading blank line. It removed the space between this parameter here. It also added spaces between the equal sign here, the assignment operator for this variable pi. It also split this line that was separated with a semicolon. And also it gives spaces here in this print statement. And also, Ruff uses double quotation marks for strings, so it changed the single quotes to double quotes. I'm going to ask it to commit to, and I think we can continue with the talk. Now let's define what is type checking. So the definition is that it's a process of verifying values in a program that match the types that they are expected to have. But in practice, it helps you to avoid the following: passing none to a function expecting a string, for example, or calling a method that doesn't exist on an object, or returning an unexpected type from a function, or even misspelling a dictionary key or attribute. Type hints let you explicitly declare types in Python. They are optional, and they have been defined in PEP 484. Some type checkers that we have in the Python realm are MyPy, PyWrite, Pyrefly, and Ty. Why do they matter? Is because they catch bug early. They can detect errors without running the code, without executing the application. That's the reason they are static tools. They give smart support to IDEs. They provide inline documentation, and they allow you to do safe refactorings. And they also serve as live documentation. So instead of passing the types in the doc string, you can directly refer to them in the type definition. And for AI, type hints give a clearer context, so the AI agent can write better code. So Ty is a type checker that is also 10 times to 100 times faster than MyPy and PyWrite. It also provides clear, detailed error messages that explains what went wrong. And why it stands out is because you have rule levels that allows you to configure per files, and also to press by line at line level. It also has a built-in language server that allows IDEs like VS Code or any fork or PyCharm to do imports, to do navigation. And Type is designed for adoption, so you can start integrating Type gradually without having to rewrite your code. There are rule levels that are configurable. We have the error, the worm, and the ignore. With error, is like any violation is going to give you an error when you run the tool. With warning, it's just going to give you a warning, not an error. And when you ignore it, the rule is going to be totally disabled. By default, all supported rules run at error level. And now let's do a real quick Type demo. Let's go back to Cursor. And I have this file for the Type demo. So you can see that right now I'm having these errors here that, for example, this function greet is a function that is expecting a string, but here I am passing an integer. So it's telling you that that is expecting a string, but it found the literal 1, 2, 3. So I'm going to run Type in this file to see the errors that we have. As you can see, it gives very explicit errors. Like, for example, here, it is expecting a string, but it found that we're passing this integer. And again, here, it is saying that this variable count, it is expecting an integer, and we're passing a string. So what I'm going to do is I'm going to use another prompt so an agent can fix these errors. So the prompt is this: run UVX type check, fix the file so it passes, then summarize what changed. I'll give you the prompt. It is verifying that now it passes. All checks have passed. And now here is summarizing what it did. So it's saying that for this function, it was passing previously this 1, 2, 3. Sorry, it was passing the number, but now it's passing the string. For this count, it was passing the string 5, and now it assigned it the integer 5. And for the append, it was appending this list. It was expecting a list of strings. Previously, it was passing just an integer, and now it appended a string. And also for the grid, it was passing none, so now it was passing a string. And finally, for these process items, it was passing a set of strings, but it was expecting a list of strings, so it also changed it. And all the checks are passing right now. Let's go back to the slides. So these tools, Ruff and Ty, they work everywhere. At least in the most popular IDEs, that we have extensions that are officially by Astral for Ruff and Ty, for VS Code and the forks, and also for JetBrains. Starting version 2025.3, it supports Ruff out of the box with no configurations needed, and it also supports Ty natively, but you have to enable it through the settings. So if we want to configure this tool more in depth, you can go to the pyproject.tom file, and you can, you can check the docs and start documenting. And this select is basically selecting the set of rules, but you can also select by rule level for Ruff, or you can also use for Ty. You have this other section in which you can enable the rules, like at error level, or warm, or you can just ignore a rule. Something that you can do is like the Ruff and Ty have skills, official skills for AI agents. You can use those tools and ask it to configure it for your code base. Also, you can set up pre-commit hooks and CI integration. So there is also an official pre-commit hook for Ruff. You can add this. So this is a dual layer approach which provides feedback locally and also in the CI/CD pipeline. So you can do it locally using pre-commit hooks, and then using GitHub Actions in your CI/CD pipeline. And some best practices for agentic coding is that we are going to have an agents.md at the repo root, and we're going to this file is going to tell the agent how it's going to work in the code base. And I just told you we have skills for Ruff, for Type, and for UV. You can install these skills, so the agentic the agent can follow these skills. And we have to guarantee that that these agents, the Ruff, Ty, and the test run when every task is completed. So we can tell it that as part of the loop, they have to make sure that Ruff and Ty and the tests are passing. Or we can set this via the pre-commit hooks too. So something important is like we can plan and then execute. Like we can have an agent to outline first. We can review the plan and then execute it. And this is an opinionated adoption letter. Like you can start. Let's say that you want to integrate these tools in your code base. So you can start with the linting. You can, in essence, is adding the Ruff check fix locally, and you can use AI agents for fixing the, when the fix or the fix and say fixes didn't work. And then you continue adding formatting with the Ruff format. This step is really straightforward. And then we introduce the type checking. And here, using AI agents is crucial because you can fix all of these errors using just an agent. And finally, when the team has agreed that they trust the tools, you can enforce it via the CI/CD tool. Or you can ignore totally what I have done what I have talked in this talk, and you can just use Cloud with this flag, danger skip permissions, okay? And you are going to get something, and at some point you are going to get your absolutely right statement. Okay, so the key takeaways that I would like for this talk is that these tools for high-quality code, they matter more than ever before, because with agents, you can write code faster, but at the same time, you need something to check the code that is being written. Astral is rebuilding the Python tooling. We have tools like UV, Ruff, and Tye that modernize the Python workflows. They are really fast because they're written in Rust. Ruff is many tools in one. You can go from using multiple tools for linting, formatting, import sorting to one tool that is configurable just by rules. And Type makes type checking easier to adopt. I think that Type is incredible because I tried to use my pipe a couple of times, and at some point I just said, like, oh no, I'm not going to go with my pipe. I'm not going to check types. And Type, in that sense, is definitely a game changer. Okay, so these are the code. I prepared a repo for this. In that QR code, you can find the slides. You can find the demo files that I got for this talk, and also you can have some documentation, and there are references to the skills that I'm talking for Tye, UV, and Ruff. And okay, so
far I have one question here. Mm-hmm. Would you be willing to write new lint rules for Ruff and other linters?
Willing to Ruff?
Would you be willing to write new rules for Ruff and other linters?
I would like to. I really enjoy, integrating tools that are useful for the software development process. So I will be willing to do something. If it brings value to the developer, the main point would be, to bring value, not to increase the friction for developing software.
Okay. I got the question, so I've got to ask it. Do you wholeheartedly adopt all of Astral's tools?
Yes, Tye is the last one that I have adopted, but I have been using UV, we have here one, Hinek. I started using UV after watching his video on YouTube. I started using UV around a year and a half ago, I think. Then I started using Ruff 1 year ago, I think, strongly. And now I'm using Tye too.
Yep. Okay. That's all the questions that I had here so far. If you have any other questions, Miguel is here. This was a great talk, both at the PyTexas meetup and here at the conference.
Thank you.